Okay, welcome back to our class for EE 137. So for week module number 4, our topic is about parallel operation of alternators. Alternators are connected in parallel in order to avoid overloading the alternator since each machine in parallel operation will share a common load. So nganong ang atong alternator is connected sa parallel. Giingon diri to avoid overloading since atong tagsa ka machine, so dapat naka-share in a common load. So when the load on a system exceeds the amount of power that a single or existing number of generators can deliver, an additional generator is connected to the system to deliver required power. So, sa atoang system, ma-detect niya if ang atoang amount sa atong power is nasobra na. So, pwede ta maka-add og another generator para makuha or ma-connect ang deliver nga gi-require nga power. So this method of adding an alternator in the existing system is called parallel operation of alternators. So mao ni siya. And it is essential to know that the incoming alternator must be paralleled such that each machine is supplying a proportionate amount of active and reactive power to the common load. So, for which certain rules are to be kept in mind. So, take note lang, pohon if makatrabaho sa mga dagkong field or dagkong factory. So, if mag-involve og alternators, so dapat naka-parallel. So, we have here our circuit diagram or given diagram sa atong alternator nga example. So, pwede ta, if natay generator 1, so pwede ta maka-add og generator 2 and generator 3. So, ang load ana nila is proportionate. So, to requirements for alternator in parallel operation, dapat equal magnitude of terminal voltage. And second is, the same ang iyahang operating frequency. So, dapat same di ay ang frequency. And lastly, the same phase sequences. So, mao na ato ang requirements for alternators in parallel operation. So, next topic, we have parallel operation problem given internal parameters of the generator. So, sa ato ang equivalent circuit, nga example, so if naatay generator A, so sa atong generator A, we have our ZA. So, unsa man ning ZA? ZA is our impedance sa ato ang generator A, and IA is the current sa ato ang generator A, and EA is the generated voltage. And for our generator B, so same, natay ZB, IB, and EB. And our ZL, or our common load, so we have here impedance per phase of the load, current of the load, and our voltage per phase at the load. So kani nga parallel operation, we can use Mellman's theorem. So, kabalo na tani sa atong Mellman's theorem. So, we have our formula. So, VL is equal to EA divided by ZA plus EB over ZB, so on and so forth. If mag-add tag another generator, divided by, since parallel operation, so we have 1 over ZA plus 1 over ZB until 1 over ZL. And to solve for our IA, sa Millman's theorem, so take note ani nga formula for solving voltage per phase at load. In Millman's theorem, solving for our IA, or the current per phase delivered by generator A, we have EA minus VL divided by our impedance per phase. So same sa ato ang IB. So EB minus VL divided by CB. And to solve for our current per phase of the load, so add ra nato, sum lang sa current sa generator A and generator V. So pwede po to solve another formula to solve for current per phase of the load. We have VL if given ang voltage per phase at the load divided by sa tuang impedance per phase of the load. And to solve for our power delivered, PA is equal to VL multiply sa tong IA cosine angle theta. So if na ay given nga angle between VL and IB, so pwede ta makagamit ani nga formula. So same ra sa atuang alternator B. So formula lang ni no. So dapat take note ta sa atuang formula. So let's have an example for this topic. So we have here two AC generators. A and B are in parallel. Each generator has an EMF of 1000 volts per phase and in phase. The phase impedance are ZA is equal to 0.1 plus J2. ZB is 0.2 plus J3.2 ohms respectively. If the common load has an impedance 2 plus J1 ohms per phase, solve the voltage per phase at the load. So sa tong problem, so naa diri ang equivalent circuit per phase para masabtan nato. So giingon nga naa siya given na common nato, EA nato. So each generator giingon sa problem has an EMF of 1000 volts. So we have our EA and EB is 1000. So given 1000 volts and our EB is also 1000 volts. And naghatag siya, ZA is 0.1 plus J2 and our CB is 0.2 plus J3.2 and ato ang common load impedance which is our ZL is 2 plus J1 ohms. So ohms ni since impedance. So we need to solve for our voltage per phase at the load. So very easy lang no, since pwede ra ta mo gamit og Millman's theorem. Since given man tanan ang data nato. So using Millman's theorem, so ang formula, we have VL is equal to EA over ZA. So duha ka generator atong given. So EB over CB divided by 1 over CA plus 1 over CB plus 1 over CL. So mara niya itong formula. So substitute, EA nato is 1000, angle niya 0, and ZA is 0.1 plus J2 plus atong EB, so same, divided by ZB nato is 0.2 as J 3.2. So substitute lang, no? 1 over 0.1 plus J2 plus 1 0.2 plus atong ZL 2 plus J1. So our voltage per phase, so calculator, we have using complex. So we have 735.18 with an angle of negative 20.61 degrees. But ang gipangayo sa problem is the voltage per phase lang, wala apil ang angle. So therefore, our VL will be 735.18 volts. So this is our final answer for our problem number 1. Since nagamit at ag theorem, so sayon ra. So proceed for another topic. So we have here parallel operation problem given external parameters of the generator. So we have here our rule of thumb. So the characteristic curve of the generator is always assume linear. So sa atong generator dapat naka-assume, always assume nga linear ang atuang characteristic curve. So for our voltage, so we have here to solve for our current deliver when terminal voltage. So sa parallel operation na rin siya ha, if na siya given nga external. So we have here our formula. If na ay given sa problem nga IFL or the current deliver when voltage is VFL. So IFL multiply to VNL, the no load voltage, minus the VL or the operating voltage or bus var voltage, divided by VNL minus VFL or the full load voltage. So take note that horizontal axis of the characteristic curve is either current or power. So depende sa problem. But here nag-assume ta nga current atuang horizontal axis. So naapod ta for frequency. So una, di ba, voltage. So for our frequency, so sa atong frequency, power ang atuang horizontal axis. So we have here PL is equal to PFL multiply to FNL minus FL over FNL divided by FL. So FNL is the no load frequency. So same ra sa voltage but frequency lang atuang gigamit. So FL is frequency at certain load and FL is full load frequency. So sa atuang speed, so frequency to ganina. For our speed, so for speed, our axis will be power. So therefore, PL, solving for our PL, is equal to PFL, power full load, multiplies ato ang NL, or the speed. So atong gigamit, N dere is speed. So speed at no load minus speed at a certain load, divided by no load minus NFL or the speed at full load. And for our speed regulation, so sa regulation we have R. So R atong gigamit. So PL is equal to PFL, full load. So atong horizontal axis is power. Multiply sa RNL, speed regulation at no load, minus the RL or the speed regulation at a certain load. And RFL is speed regulation at full load. So tanan na siya formula. So given na siya, no? So pwede ra ninyo tan-awon diri if depende sa problem given if unsa ang gihatag. So let's take note sa to formula, no? So lahi siya. Magdepende of frequency, speed regulation or voltage ang gihatag sa problem. So let's have here percent speed regulation of generators. So percent rise in speed of the primer mover to a generator when its electrical load is switched off or unloaded. If the load is applied to the DC motor or machine, the speed of the motor decreases automatically. So giingon dire if ang atuang load di ay if naka-connect siya sa direct current nga motor or machine, so automatically ang speed sa atuang motor mo decrease siya. Thus, to maintain the constant speed, the difference between no load and full load speed, so ginatawag nga speed regulation, should be maintained very less. So we have here our formula for speed regulation, percent speed regulation. We have N and L. So speed of no load minus speed at full load divided by speed at full load. And to solve for speed at no load, so we have here is equal to full load 1 plus percent regulation sa atuang generator. So let's have an example for parallel operation. So we have here two identical 2000 kilovolt ampere alternators operate in parallel. The governor of the first machine is such that the frequency drops uniformly from 50 Hz on load to 48 Hz on full load. The corresponding uniform frequency drop of the second machine is 50 Hz to 47.5 Hz. So solve the kilowatts shared by each machine if total load is 3,000 kilowatts. So first, we need to solve for our, so isulat na to ang given. So given sa ato ang problem, giingon siya nga naay two identical kilovolt alternators. So we have our P full load. We have 2,000. And our frequency at no load is, so there no, i-highlight ni ma'am. So ang frequency nato is 50 Hz. And our for full load we have 48 Hz. So for P1 ni siya, no? Since duha man ang given. And for P2, so ato ang PFL, same man sila to, identical. So 2,000 kVA. And our FNL, no load nga frequency is 50 Hz gihapon. So giingon dire 50 hertz, and our full load will be 47.5 hertz. So we need to solve for the kilowatt shared of the machine. So dapat ma-solve nato ang P1 and P2. Ang giingon nga ang P1 plus P2 daw, total nila is 3,000 kilowatts. So giingon sa problem. So nasulat na nato atong given. So pwede na ta maka-analyze if unsa ato ang unahon pag-solve sa ato ang problem given. So to use our gamiton nga formula, sulat ni ma'am. So PL is equal to PFL FNL minus FL divided by FNL minus FFL. So mani ato ang formula nga gamiton. So substitute data for our both machines since identical sila. So we have here for our P1. So P1 is 2,000. 50 hertz minus atong unknown. Wala tayo given ana. Divided by FNL 50 minus frequency sa full load 48. And for P2, so 2,000 same ra, 50 minus ang unknown FL divided by 50 minus ang frequency sa iyang full load lahi, which is 47.5. So very taas, no? So take note that P1 plus P2 daw is equal to 3,000. 3,000 kilowatts. So substitute na to. So paano ni ma'am para dili magdikit. Substitute 2,000 L 50 minus 48 plus 2,000 50 minus FL, so over 50 minus 47.5 equals 3,000 kilowatts. So wala na gisulat ni ma'am ang kilowatts since 2,000 ra pud ang gisulat ni ma'am instead of kVA. So cancel naman, no? Nawala na ang kilo. So therefore tagsa-tagsaon natin ni pag-solve para mas klaro. So 2,000 times 50, so we have 100,000. Sakto ba? Distribute na to. Minus 2,000 F divided by 50 minus 48, 2 plus same ra dire 100,000 minus FL ni siya 2,000 FL divided by 50 minus 47.5, we have 2.5. So equals 3,000. So 100,000 divided by 2, we have 50,000. So 2,000 divided by 2, 1,000 FL plus, so 100,000 divided by 2.5, we have 40,000 minus 2,000 divided 2.5, we have 800 FL. So na-simplify na nato, no? So mas dali ra i-solve. So combining same variable, so 50,000 plus 40, we have 90,000 minus 1,800. So FL, same sila, divided by 3,000. So to solve for FL, so transpose, so 1,800, so 90 90,000 minus 3,000 divided by 1/8 para ma-cancel out. So ang mabilin FL sa tong FL nato, FL is the frequency at a certain load. So FL is equal to 48.33 Hertz. So nanatay FL, so pwede na ta makasolve sa atuang kilowatt shared by each machine. So substitute nato ang natong na-solve nga FL. So sa P1, we have 2,050 minus FL na to 48.33 divided by 50 minus 48. So our kilowatt shared in machine 1, we have 1,667 kilowatts. So nanatay answer for our machine 1 nga kilowatt shared. And for P2, so P2 is equal to 2,050 minus 48.33 divided by 50 minus 47.5. Our machine shared in number 2 is, calculator, 1,333 kilowatts. So this will be our final answer for our example problem. So very long ang procedure, no, since gisimplify gyud og ayon ni ma'am. So diri nga side pwede ra mo maka calcu, shift solve. So gipakita lang ni ma'am in case di kabalo mag shift solve. So pwede na to i step by step process para makabalo jud mo. So if you have any question for our topic, this module number 4, so you can ask me sa Google Classroom. So I hope you understand, and thank you and God bless.